27, the directions say, graph the function x squared minus 4x plus 5 on your calculator. All right, so I graphed it, and here's what it looks like. It has a vertex at 2, 1, and it opens up. It just so happens that this parabola does not cross the x-axis right here. That's going to be important in this lesson, okay? Why? Because usually parabolas cross the x-axis in either two places, if it's like this, or one place if it just bounces off and has its vertex on the x-axis. Okay? So for question A, it says, does the graph cross the x-axis? We're going to say no. Does the equation of x squared minus 4x plus 5 have any real solutions? The answer is no. Main reason being that it does not cross the x-axis. And mathematically, this is why. For part C, they want us to use the quadratic formula to solve the equation x squared minus 4x plus 5 equals 0. All right, so if you need help memorizing that quadratic formula, watch the video in the Chapter 5 folder in Schoology. It's really good. It'll help you memorize it. But basically, you want to make sure that your polynomial is in standard form. Standard form means it's set equal to 0, and that your exponents are decreasing. So x squared, x to the first, x to the 0. Then you can determine your a, your b, and your c. So in front of the x squared, there's a number that you can't see. It's a 1. That becomes our a. In front of the x is a -4. That becomes our b. And the constant term is 5. That becomes our c. Those three numbers plug in, okay, to the quadratic formula, which is x equals -b, which is -4, plus or minus the square root of b squared, which is -4, minus 4 times a, which is 1, times c, which is 5, all over 2 times a, which is 1. The first time you write it, only plug in. Do not try to simplify until the next pass, okay? Now we're going to simplify. The opposite of -4 is +4. Rewrite the plus minus. Rewrite the square root. -4 squared is 16. And then -4 times +1 times +5 is -20. And then in the denominator, we have 2 times 1, which is 2. We can simplify under that radical a little bit more. So we're going to have 4 plus or minus the square root of 16 minus 20, which is -4, all over 2. Normally at this point, because you have a negative number under that radical, you'd say no real solution. But now you know about imaginary numbers, right? So the square root of 4 is 2. That's where this 2 comes from. And the square root of -1, which is a factor of -4, is I. So we say plus 4 plus or minus 2i over 2. And normally you'd be done, but in this particular case, both of these terms are divisible by 2. So 4 divided by 2 is 2, and 2i divided by 2 is just I. So the answer is 2 plus or minus I, which is not a real number, which is why this quadratic does not cross the x-axis. Okay? So part D says, use your new understanding of imaginary numbers to rewrite your solution to part A, to part B using I and not with the square root of a negative number. Simplify as much as possible. Basically, we have two answers. One is 2 plus I, and the other one is 2 minus I. You can write them separate like that, or you can write them using the plus minus symbol. Okay? Part E says that a real number, plus or minus a multiple of I, like each of the solutions to x squared minus 4x plus 5 equals 0, is called a complex number. check one of your solutions from part B by substituting it into the equation for x and simplifying the result. So you can choose either of these two. I chose the first one just because it came first, no other reason, and plugged it into this equation right here. So in for this x, I plugged in 2 plus I, and in for this x right here, I plugged in 2 plus I. And then we simplify. So this first one you have to FOIL out. You get 4 plus 4i plus I squared. Here you're going to distribute. Negative 4 times 2 is negative 8. And negative 4 times I is negative 4i. Plus the 5. And then we can simplify. That just means combine like terms. If you combine any like terms, we've got a 4 minus an 8 plus a 5, which is 1. The 4i and the negative 4i are opposites. So notice I didn't even write it. And then we have the I squared. I squared, by definition, is equal to negative 1. So we have 1 minus 1, which is 0. So that's just showing that that answer works. If we'd used 2 minus I, we would have also gotten 0. So you can use either one. Okay? All right, let's look at question 128. In problem 127, you found the solutions to a quadratic equation. X squared minus 4x plus 5 equals 0. The roots of a polynomial function are the values of x where f of x is equal to 0. You have seen that solutions to equations can be real or complex, so it follows that roots can also be real or complex. Compare and contrast what happens with the graphs and equations for the 3 cases in parts A through C below. For part A, they want us to sketch the graph of f of x equals x plus 3 squared minus 4. Use the graph to determine the roots of f of x. So I did parts A, B, and C in 3 different colors. I did A in red, it's this parabola right here. I did B in yellow, it's this parabola right here. And I did C in green, it's this parabola right here. You can see that they're basically the same shape. They're all parabolas. They're just shifted, okay? The first one, A, is graphed and it crosses the x-axis at negative 5 right here and negative 1 right here. It's going to end up having 2 real solutions, okay? Part B touches, or what we call bounces off of the x-axis, has a double root. It crosses the x-axis at negative 3. Part C says a slightly shifted quadratic. Can you determine the roots by looking at the graph? This one is shifted way up above the x-axis, does not cross the x-axis, therefore it does not have any real roots. Okay? So question D says determine the roots of the x plus 3 squared plus 4 by solving an equation. Write your answer as complex numbers. Okay? So if we take that equation and set it equal to 0, we're going to do inverse operations until we get the x by itself. So since 4 is being added, we're going to subtract 4 from both sides. Since x plus 3 is being squared, we're going to take the square root. When we take the square root, we get what's inside, which is the x plus 3. When we take the square root of negative 4, we end up getting the square root of 4, which is 2, and the square root of negative 1, which is I. So it's 2 plus or minus the 2I. That's what that radical simplifies to. And then the last step is to do the inverse of adding 3, which is subtracting 3. Okay? So the complex answer is negative 3 plus or minus 2I, which is 2 answers right there. One is negative 3 plus 2I, and one is negative 3 minus 2I. So at the bottom of page 128, they want us to describe in words the relationship between the graphs of the parabolas, the kinds of roots their equations have. Okay? So there's 3, and I accidentally left a word out right here. It should say touches. Okay, so the first one is if the graph crosses the x-axis like the red one did, it's going to have 2 real solutions. If the graph touches the x-axis like the yellow one did, it's going to have 1 real root. And if the graph does not cross the x-axis like the green one does, it's going to have 2 complex roots. Question 129 says the sum of a real number and an imaginary number, such as 2 plus 3i, is called a complex number. A complex number can be written in the form a plus bi, where a and b are both real numbers. Use the definition of I and your understanding of real numbers to rewrite each of the following expressions.